Hello everyone, today I will show the use case of the proactive maintenance, and for that I will introduce a new application in the waylay portfolio, which is databridge. Databridge allows you to proxy different protocols towards the waylay platform, but at the same time allows you to stream the data into the cloud storage system. Now this REST call is very similar to the one that I've shown in the previous videos, but there are some specific things that I would like to emphasize here. The first one is that when you do the REST call, you will need to provide domain because it will be the private domain and private storage for you. You'll obviously have to make use of the API keys and the secrets. And also you have a test resource, let's say the resource, with which you're going to associate different parameters, like in this example. Now, like I said, next to the REST, you can as well do the same thing using the WebSockets or MQTT. So the calls are pretty much the same, except that we use different protocols. And like I said, as soon as you invoke such a call, it will forward this information towards the waylay application and at the same time or in parallel stream it to the data storage. Now, if you connect with your keys into that bridge, you will be able to test and push some data into the cloud. So in this particular example, I have logged into the data bridge with my keys and into my domain. And I'm just pushing for this resource some different temperatures, like for instance 30 degrees, pressure 99 or 1, and that will be then sent to the waylay platform. At this moment in time, I have not created the task. There is nobody waiting for this data parameter to be processed. Nevertheless, the data is already available in the cloud storage of the waylay application. Now let me show you one sensor that I created which make use of this data storage part of the of the story, if you like. So if I would like to see what I have pushed into the cloud, you see immediately here that I have created a sensor which fetch this from the storage and gives you back the temperature 40 degrees and other things that I just typed in. If you would like to test that with the different values, let's put here 23 degrees. Now if I go back here and test it again, I will get back a temperature 23. If you see how I created that sensor, I actually use another feature of the data bridge, which was to retrieve the data which is stored in a data cloud, again hitting the same endpoint, but here I'm going to say for resource with the thing that was input parameter for a domain, and I will retrieve back the current value which is stored in a database. Here I used the default domain. If it's not provided, it will be simply my own domain. And I made again use of the keys. And for the resources, I will either use the input arguments or they will be inherited from the task. So again, if I hit here and I see HVAC 1 again, I will get indeed back the values that we pushed to the cloud. There is another sense that I created which makes use of another REST call that is put on the top of the data store, and which is actually giving the complete series of the data points. And here the call is pretty much the same, but rather than giving you one value, it gives you all data points that are stored in the database. Now what I have created here, it's a small JavaScript which does the statistical computation on top of that. And again, if I hit here HVAC 1, I will get back the min, max, and average values of every parameter that is in a database and the number of samples that resides there. And you see here in the log what actually that REST call includes. It includes all data points which are in a database. Now that we have seen that, I can introduce you to the current use case that I'm going to show you today. And that one will mix the data which is already stored in a database with the data which is coming to the system at the runtime, and I've also mixed that together with information about the weather forecast for Ghent. Let me show you what I mean by that. First of all, I will check the temperature difference between the outside and inside temperature, and if that happens to be more than 10 degrees, I will then send myself an email. It's a very simple thing, not that much, and I will be using the latest value which is stored in a database. For this particular formula, I will use the temperature which comes from the global context, meaning that it has somehow to be passed from the bridge into the running task. Then I will check for the vibration spikes, and in order to do that I will use a formal computation which compares the current value versus the value of the last 3 samples. So this is what you can see here. And again, if I see some vibration spikes, I'm gonna send myself a message, and since I'm working in the debug mode, I will simply pop up a window. Finally, the last thing that I'm actually interested in is the pressure, current pressure versus the maximum pressure ever recorded for that particular resource. So in order to do that, I will be checking the current pressure which comes into the system versus the maximum pressure ever recorded in the system, for which I will be using the sensor which does the statistical computation. And again, if that turns out to be true, I will send the alarm, and I will say at the same time I will set myself a tweet, and I will set it on my account. Okay, good. With this we are ready to go. I will have now associated this task to the HVAC 1, because then every sensor here will be taking that as a default parameter, default resource, and with that I will be able to fetch and compute everything that is required to run this use case. Very good, let me just start that. And at first, not that many things will happen. Actually happen only 3 things. The first, obviously, I'll be able to fetch the weather forecast for Ghent, and I will be able to collect the data points from the database. And as you already, I'm going to send myself an email, because the temperature now between Ghent and my temperature in the room, it's actually 22 degrees, meaning that it's more than 1, and I'm receiving this notification. But all other sensors are actually not working, or actually they are working, but there is no data points. And this is the current temperature, because I have not started pushing anything into this current task. So let's start with putting the temperature, let's say 25 degrees. Let's put the pressure 120. No, let's keep it 111. I don't want to 100. Vibration 16. Right, so let's put that. And let's see what happens. So I have put the temperature to 25 degrees. So I should now be able to check the temperature crossing versus the one that was put in the threshold. It's not that cold, so I'm above 20 degrees. And vibration spike has happened because I indeed have decreased the vibrations. And this is something that you can actually see in some of these things here. So there was something here that you see as well. Now, let me now increase the pressure, because what I would like to see now is that I would like to get an alarm if the pressure suddenly has increased. So in order to do that, I will put the pressure to 120, and I will push that into the system. Now, what should happen is that here, at this moment in time, I'm checking whether the current pressure, which is now 120, it's higher than any the temperature, the pressure, sorry, that has ever been recorded. And let me see now what I'm receiving here. All right, apparently there was at one moment the pressure which was higher than that. So let's increase it even further to 125. And all right, good. So the maximum pressure now is 125, and it's higher than the one that has ever been recorded in the database. Now you see as well at this moment in time that I'm getting the tweet about the pressure alarm, and if I go back into my Twitter stream, I should be able to find here the alarm saying that maximum pressure can increase to 5 from 120 to 125. And by the way, if you'd like to fix that device, you should get into this location, because this is where it's physically located, this device. So with this use case, I think I have shown you how you can actually mix the runtime data with something which comes from the data store, and I also explain you how you can use the data bridge. Now, before I close, I would like to show you one more hack, which comes by combining the feeboard with waylay. Feeboard actually, it's another funny application that allows you to associate your data streams with the dashboards and then make nice dashboards which you can share with other people. So in order to do that, I have created a stream of a type JSON, and here I put the URL to the current data points that I will be using to plot it on the dashboard. And I also use the authentication headers and also the basic authentication keys that are given to you. Now that I've done that, I can actually here create some dashboards which are simply associated with the sources that are found in the JSON response object, and then create nice dashboards of this sort. So for instance, again, if I'm going to change the temperature to, let's say, 18 degrees, we would see here that the temperature, because it pulls verifies that okay, has dropped to 18 degrees. And you see here again that we see the information about the same device as if it was from here. Now, interestingly enough, as I have changed the temperature to 80 degrees, I got an alarm here from this actuator that indeed the temperature has dropped below 20 degrees. Now that we are happy with this template, let's just push it in the cloud and let's give it a name HVAC, and I will associate with this one with the HVAC 1, and that will be used in the task resource identifier. It will be used for the computation. Again, it's the same thing. We see here now that this task is running in the cloud, and as we start pushing the data, it will then start doing the logic. And here again we start getting the emails, because again we have started now this task in the cloud. It's not anymore in debug mode. And if we would like to see now again some kind of a widget, we see here that what is the temperature inside and outside, and indeed we see again the same thing here. We see what are the values at this moment in time of the temperature and other things of this HVAC which we are monitoring. Okay, that was all for today. I hope you like it, and till next time, that was all from me. Thank you very much, and bye-bye.